Welcome back to my channel. In the series of making concepts simpler to understand, today we will do sign conventions for mirrors. As you know that this is a concave mirror which is curved inside. I have already written the mirror formula and the formula for magnification as well as the variables that we use in both the formulas. Now sign convention basically means that what signs should we use, that is positive or negative, when we are putting these values in these formula. There are two basic rules for understanding sign conventions. The first and the foremost rule is that all distances are measured from the pole. If you have to measure the focal length or you have to measure the distance of the image or distance of object, it will be always measured from the pole. We have to start from the pole and move in that direction to measure the distance. Second rule is all distances which are measured in direction of the ray will be taken as positive and opposite to the direction of ray will be taken as negative. The third rule says the height of any object. Now suppose if I place my object here, then height of my object will be from this principal axis to the topmost point. So any distance which is measured above the principal axis will be taken as positive, and any height which is measured below the principal axis will be taken as negative. So if you remember all these basic rules, you will never make mistake in substituting the values with proper sign conventions. Okay, let me give you an example here. Now this is a concave mirror, and suppose if I place my mirror like this, you can see this area, the lined area shows that it is painted. So there can be no reflection from this side. The reflection will always be from this side. So I have to place my object in front of the mirror. I will have to measure the distance from pole of the mirror to the object. Now we will be applying the rules of image formation. The light ray will go parallel to the principal axis. Now just look at the direction in which this light ray is moving. If I have to measure the distance of my object, I will keep my scale like this, 0 at pole, and I will start moving this side to measure the distance. So direction of measuring the distance is opposite to the direction of the ray. And whenever the distances are measured opposite to the direction of the ray, they will be taken as negative. Okay, so in this case, the position of object will be taken as negative. Now let us see the focal length. Distance from the pole to the focus is called the focal length. I will place my scale like this and move in this direction to measure the distance. Now again we will compare this direction with the direction of the ray. It is opposite to the direction of the ray, so the focal length will be negative. Since the object is placed beyond C, and if you remember the diagrams, you know that when the object is placed beyond C, the image is formed somewhere between C and F. Okay, so the distance from the pole to the image is V. So again I will keep my scale like this and move in this direction to measure the distance of the image. This direction is again opposite to the direction of the ray. So it means V will be taken as negative. But you know that in concave mirror, the first 5 cases, image is always formed in front of the mirror. You can look at the first 5 diagrams given in your NCERT book. But in the last case, the image is formed behind the mirror. And since it is behind the mirror, I am showing it with a dotted line because it is a virtual image. Now I will have to move from pole to this position, and this is the direction of measuring the image. Now look at the direction of the incident ray and the direction in which we are measuring the distance. So the image distance will be positive only in the last case, but in rest of the cases the distance will be negative. As you can see that we always place the object upright. So whenever the object is erect, it is placed above the principal axis, positive, and height below the principal axis is negative. So here if I look at this image, we can see it is inverted and it is below the principal axis. So in that case the image will be negative. But if I see the last case where the image is also above the principal axis, object is above the principal axis, the image is also above the principal axis. So in this case the image will also be positive. You must remember that these rules are same for concave and convex mirror. Let us start with the convex mirror. The first and the most important thing is you should remember that the object is never placed towards F and C because these points lie behind the mirror and you are placing the object in front of the mirror. Okay? Okay. Now let us start with the sign conventions. F. The distance, again the rules will remain the same. The distance has to be measured from pole. So I will move in this direction to reach the focus. And this is the direction of the ray. Let us see the direction of the ray and the direction in which we are moving. Both the directions are same. So F will be positive. In a convex mirror, the focal length is always positive. If you have to measure the position of the object, you have to move from the pole to the object, that is in this direction. Now both these directions are opposite. So U will be taken as negative. Now let's talk about V. In this case, you know that wherever you place the object, in case of a convex mirror, the image is always formed behind the mirror. It is always virtual and erect, always formed between F and P. So if you have to measure the distance of image, you will have to move from the pole to this position. So that is again in this direction, and both these directions are same. So again V will be positive. Let us see the height of the object and height of the image. I have to measure the height in upward direction. So height of object will be positive, and the image is also above the principal axis. So that is why the height of image will be positive.